Good morning, everyone. So, in this video, we are discussing the exact differential equation. In previous video, we already discussed the differential equation. That is, what is meant by the differential equation, what is the different types of differential equations, and what is the solution for the differential equations. In that video, we all discuss, and also we have discussed one type of the differential equation is linear differential equation. So other type to solve the other method to solve the differential equation of first order and first degree differential equation and is exact differential equation. So exact differential equation means let m of m dx plus n dy, where m is also a function of x and y, and n is also a function of x and y. So both m dx plus n dy is equal to 0. It is said to be a first order and first degree differential equation, where m and n are real valued functions, that it has a only real values function. So it is both the real value function and it is also function of x and y for defined for some reals, that is x comma y. Okay, so any equation is of the form m dx plus n dy equal to 0. It is said to be exact only if, okay, only if dou m by dou y is equal to dou n by dou x. So if any equation is the form m dx plus n dy equal to 0, it is only said to be exact. It satisfies the condition dou m by dou y is equal to dou n by dou x. So we are now that we will say the working rule here. So if any equation is said to be an exact, so we need to follow these rules. So first one, so they have to compute dou m by dou y and dou n by dou x. They have to compute dou m by dou y and dou n by dou x. So if these two values will be equal, so dou m by dou y is equal to dou n by dou x, so it is said to be exact. So it is said to be exact. So then we have to find the solution for this exact differential equation. The solution is integral m dx. So treating y as a constant here and plus integral n dy contains only y terms. Contains only y terms. So finally we get, so finally integration is completed. We have to keep the integration constant. So this is the general solution for exact differential equation. So we will discuss one problem to solve the exact differential equation. Okay. So let us consider. So first one, e power y plus 1 into cos x in dx plus e power y sin x dy. Okay. So this is the one differential equation equal to 0. If so, what we have to solve? So if this differential equation is an exact differential equation. So when we compare with m dx plus n dy, here m is e power y plus 1 into cos x. Then n is e power y sin x. So we have to do partial derivative here, that is dou m by dou y. In partial derivative, what we are doing with respect to derivative, with respect to variable of derivative, so that is only a variable and remaining all are treated as a constant. So we are doing the derivative with respect to y, so we are treating y as a variable and remaining all are constant. So here e power y. So Generally, we are product of two functions. We always do the UV formula, but here if we need not to do the UV formula, why? Because this is considered as a constant. So we will keep the constant aside, and e power y derivative of e power y is e power y, and derivative of constant is 0. So we will get e power y into cos x. And then dou n by dou x we have to calculate. So it's in the same manner. That is, we are doing partial derivative with respect to x. So we have to keep y as a constant. So derivative of sin x is cos x. So finally we get dou m by dou y is equal to dou n by dou x. So finally we can say that it is a exact differential equation. Okay. The exact differential equation, we need to solve the solution. So that is integral m dx plus integral n dy is equal to c. So here m means only y as a keeping y as a constant, and here n is it contains only y term. So that means x. We need not have the x terms. So that is integral e power y plus 1 into cos x dx. So in n, so if there is any y value, only y value, we need to have only y value. So it is a mixture of y and x. So we don't have the only y value here. So keep 0. So that equal to c. So that means e power y. So e power y plus 1 is the constant here. So we have to keep outside. So integral of cos x means sin x. Integral of cos x is sin x. So 0 is 0 here, that is equal to, so C. This is the general solution for this exact differential equation. So one more problem we need to solve, that is if dou m by dou y is not equal to dou n, then what will be happen? So it is not an exact differential equation. So how can we convert it into exact differential equation? By using some integrating factor. So we multiply the integrating factor, then again it becomes to the exact differential equation. So we are doing some non-exact differential equations. So that is the differential equation. Now we are discussing the rule. So if if m dx plus n dy is an differential equation, if dou m by dou y is not equal to dou n by dou x, then we say that it is not exact. Then what we have to do? So it is not exact. If you multiply some number, some value or some function with this equation, it will get exact. So that function is said to be an integrating factor. So there are there are five types of the integrating factor. If you multiply it, it becomes exact. So we will discuss one of that integrating factor is 1 by mx plus ny. So this is the integrating factor. When we multiply it with this differential equation, it becomes exact. So then we can find the solution for exact differential equation, that is m dx plus n dy. So this is the working rule to find the one non-exact differential equation. Okay, we will discuss one more problem in non-exact differential equation. See, x square y dx minus x cube plus y cube into dy is equal to 0. Okay. Here m is x square into y. N is minus x cube plus y cube. Okay. So dou m by dou y. We need to compute dou m by dou y. Here y is the variable, x square is the constant. Derivative of y is 1. and dou n by dou x. So here x is the variable, y is the constant. Derivative of x cube is 3x square and derivative of y. So y is here constant. So we have the 0. So finally dou m by dou y is not equal to, do you observe? So dou m by dou y have x square value, dou n by dou x have minus 3x square value. So this is not equal. So it is not a exact differential equation. So then we need to do the exact. So we have to find the integrating factor, that is 1 by mx plus ny. So here m is x square into y. So we need to multiply x square into x. So we get x cube plus y, and the next y n value here is x cube plus y cube. So we need to multiply with y. So we'll get minus x cube y minus y power 4. So x cube y will get cancelled. We get 1 by y power 4. This is the integrating factor. When we multiplied integrating factor with given differential equation, so we will, now what will happen is x square multiply 2 with x multiply 2 with 1. Okay, multiply 2 with 1. So then x square minus x square y by y power 4 dx, minus into minus will get plus x cube plus y cube by y power 4 dy is equal to 0. So we need to solve here. Minus x square by y cube dx plus x cube by y power 4 plus 1 by y power 4 dy is equal to 0. Now we have to calculate dou m dash, dou m1. So let's take m1 here, minus x cube y x minus x square by, sorry, minus x square by y cube. N1 is x cube by y power 4 plus 1 by y. Okay. So again we have to compute dou m by m1 by dou y. So ma x square will keep constant side, and y power minus 3 we can write as y power minus 3, that is minus derivative for y power minus 3 is minus 3 into y power minus 4. Finally we get 3x square by y power 4. Okay. And next dou n1 by dou x. So here y is the constant. So keep y, derivative of y is 0. So here x cube is, derivative for x cube is 3x square by y power 4. So finally we get 3x square by y power 4. So finally dou m1 by dou y is equal to dou n1 by dou x. Okay. So finally we get the exact differential equation. So find, you have to find the solution. So that is general solution, integral m1 dx plus integral n1 dy is equal to c. Here m1 is minus x square by y cube dx plus integral, only we need to have only y terms. Here the only y term is 1 by y, that equal to c. So we are doing the integration here, minus 1 by y cube is constant, derivative of x square is, integral of x square is x cube by y cube. So integral of 1 by y is log y. So finally we complete the integration. So then The general solution is minus x cube. Okay, sorry, sorry. So derivative of x, integral of x cube is x cube by 3 here. Okay, so finally we get minus x cube by 3y cube plus log y is equal to c. So this is the general solution for non-exact differential equation. So in this, we are both discussed about exact and non-exact. Hope you all understand. Thank you.